These are the notes for day 9 unit. It says unit 8, but this should be unit 10. So that is a mistake right there. These are the domain and range of common functions. And just to review, remember the domain is the list of all possible x values, and the range is the list of all possible y values. We're going to use interval notation again here because with these equations, there's an infinite number in this set, so we're not going to list particular elements. So we're just going to look at some basic functions. We're going to start with a linear function, so it's like y equals mx plus b. So it's your basic linear function. I don't know, let's put a negative 3x plus 1, right? Something like that, where it's just x to the first power. And again, think of our domain as like what x values are allowed. And in this case, in a linear function, you could plug in whatever value you want. And you can get any kind of value out of that. We're going to stay away from like horizontal and vertical lines. We're just talking about, our linear functions. When you have a quadratic function, we are simply looking in vertex form. So in a quadratic function, we are squaring the x value, and you can square any number you'd like, positive, negative, 0. In this case, usually the shape of the graph, well, the shape of the graph is always going to be a parabola, but it could open up. So that is in the case that I have a positive a value, right? So the coefficient of x squared is going to be positive. If it's negative, what that's going to do is that's going to flip my graph over. So my graph is going to go negative infinity to the k value. So we're going to keep it pretty simple with these. Again, your parabola is either going to open up or down, right? So it all depends on, what my graph would look like. Now, I did the next one. Sorry, I got a little bit ahead of myself. So if you have a negative quadratic, we'll just move this right down here. Your domain is going to be negative to positive infinity. But if that a value is negative, that flips your graph over. The rest of these are going to be pretty uninteresting except for rational. So a cubic graph, you can cube any type of number that you'd like. So that's negative to positive infinity. And my graph is going to look something, this isn't a perfect representation, but it's going to look something like this. So it's also going to decrease. You can see on that left-hand side, it's going down forever. On the right-hand side, it's going up forever. We can flip those around, but you are going to see that it is going to, there is no bottom to the graph and there is no top. When I do a cube root, you're going to get a graph that kind of looks almost like an S shape, kind of. And you're going to end up with the same thing. And again, if you think of x values as what is allowed, you can plug any value you want into a cube root. You can take the cube root of a negative, a positive, a 0. So I know I kind of refer to those three categories. In our range, we can get out whatever values we want. And again, it's going to be kind of going down forever and then up forever. Now, our rational function, we have to be careful because this denominator cannot end up being 0. So x minus a cannot equal 0, right? So what we're going to say is that there is a value that's going to make that denominator undefined, right? And most values are going to be okay for us. It's just that one value. And we're going to stick to pretty simple rational expressions. We're not going to get too crazy with these rational expressions. So what you can do is you can just set this equal to 0, right? And that is the value we cannot have. So normally it's going to look like this. We're going to say x cannot equal whatever a is. And anything smaller than that is fine. So we're going to say negative infinity to a. And then we're going to say we don't want brackets because a is not allowed. And we kind of jump over a. And then we go to positive infinity. So we just have a little interruption there at a, and everything is fine. We're not going to talk too much about the range. We're not going to get into graphing rational functions, but it is important to know where that domain gets interrupted. Now, on the next set of problems, feel free to come back up and use this chart whenever you want. I'm just going to walk through some of those problems down there and talk through some of them. But it's up to you to kind of like come back up to this chart. We'll have this chart for reference on the test as well. So this first one, this is a quadratic function. And on a quadratic function, my domain is negative to positive infinity. The range, we're looking at this 3. And since a is positive, right, a is positive 5, there's my a value right there. My range is going to go from the k value, which is 3, to infinity, right? This graph, looks something like this. It's going to be opening up. Now, on the next one, this is another quadratic function, but that's whatever we do is not going to have any effect on the domain. But my a value here is -1, right? So there's a -1 out front. So that is going to flip this graph over. So what that negative does is it flips my graph. So now it opens down. So it has a top at that k value of 3, right? So here's my k value. Oops, sorry. It has a top at 3. I said it right, wrote it wrong. But it doesn't have a bottom. So it flips over, and then we end up with the graph going up to 3. Okay, so sorry for the confusion on that one. Example 5, this is linear, right? So if you think about what this graph looks like, it's just a line. It's got a negative slope, right? It's going to be looking like something like that. That's a linear function. We're going to go from negative to positive infinity for both the domain and range. So if you look at that little sketch I did, that line is going to the left forever, it's going to the right forever, it's going down forever, and it's going up forever. And then we have our cube root. The cube roots, as we said, pretty uneventful. You can take the cube root of any kind of number you want. So the domain and range here, we end up with negative to positive infinity. Not much to think about there. Number 9, we just kind of mix this up. But if I write this in standard form, this is just a linear function. It's x to the first power. And again, we already saw linear. That's negative to positive infinity. So sometimes, they'll try to confuse you with the form, but that is strictly linear. Okay. Now, 11, we get something interesting. We have our rational expression. So what we want to say here is for my domain, and we're going to ignore the range. I'm not going to ask you about the range. We cannot have our x value equal -2, right? If I plug in -2 down there, it's going to be -5/0, which is undefined. Any value less than -2 is okay. Any value greater than -2 is okay. But -2 is not okay. So what we do is we say any value less than -2, you're good. Remember, this is a parentheses, not a bracket, because we don't want to. We want to kick -2 out of this domain. So everybody but -2 is fine. So we just have that little jump at -2. We kind of jump over it, and then we're good to go. Now for these last few, we're just asking where the function is undefined. So where the function is undefined, you take the denominator, x minus 9, and you set it equal to 0, because we're saying we don't want x to equal 0. So I add 9 to both sides, so the function is undefined at 9. Okay. Thanks for watching the video. We could do the rest of those problems in class.